Bismillahirrahmanirrahim. Inshallah, today I will talk about chapter 3, the beginning of the chapter 3 material. Just this chapter is about um, nth roots and rational expressions uh, and radical functions. That's like y equals 3 square root of x minus 5. Okay, so an example of a radical function. So the first part of the chapter, however, is about exponents that are fractions. So before we do that, I'd like to just review some of the rules of exponents that we already know. For example, when I say x cubed, this really means x times x times x, or x multiplied by itself 3 times, like this. So, and when I say x to the x cubed times x squared, therefore this means that x times x times x multiplied by x times x, like this. And regarding these, we had already previously learned some rules. For example, a to the m times a to the n equals a to the m plus n. So this was x cubed times x squared. This was x to the fifth. Right. So you just add the exponent in that way. And then we had a to the m over a to the n. Then you set a to the m minus n, like this. So this was like x fifth over x squared. This is x to the 5 minus 2, or x cubed. Or the way I imagine this, there are 5 x's on the top, and there are 2 on the bottom. And these cancel each other out, and there are 3 left in the top. But nevertheless, that's the rule for exponents. Okay. And then we had this rule, a to the m to the power n. This was a to the m times n. So an example of this would be x to the fifth to the squared would be x to the 10th. Okay. And then we had a to the minus m was 1 over a to the m. So we have x to the negative fifth would be 1 over x to the fifth. Okay. And finally, a to the 0 is 1. Anything to the power of 0 was 1. So these are some exponential rules that we have already previously learned. Just as a point of clarification, it's minus 2x to the negative fifth. So this negative 5 belongs entirely to the x. In other words, there's a distinction between this expression and this expression. So this expression can be rewritten as negative 2 over x to the fifth. And this would be 1 over negative 2x to the fifth. Okay. Which also reminds me, we have another rule, ab to the m is a to the n times b to the m, like this. Distributing this. Now you can't distribute this, of course, that would be wrong. You have to FOIL that, okay, so to speak. So this is one rule also. Now today, that's review. So today I'm going to talk about what it means when you have something like 7 to 1/2. What does that mean? Okay. Well, when we say square root of 25, and this is 5, okay, there's a 2 over here that we typically don't write. Okay, so square root of 25 is 5, and then second root of 16, or square root of 16, is 4. Okay, so when we say square root of 16, that means what number multiplied by itself gives you 16, and the answer is 4, and hence the square root of 16 is 4. Okay, now square root of 25 can be rewritten as 25 to the power of 1/2. Okay, that's what the second root of 25 means. Okay. Now, in general, then we can say this: a to the power of m over n is the nth root of a to the m. So this is the key concept here that you have to appreciate. A to the m over n is the nth root of a to the m. Okay, the way I remember is it's like if you can imagine, like this is soil, right, and this is a tree. Okay, and what's on the bottom are the roots. So if you have a fraction like m over n, this is the root, the nth root, and this just stays on the top. So this is the root, the nth root of a. So like this. So a to the m over n is the nth root of a to the m. What does that mean? So what does nth root mean? Okay. So if you have 16 to 1/2, this can be written as the second root of 16, which means what two numbers multiplied by themselves will give you 16, and that is 4. Then if you have cube root of 8, this means what number multiplied by itself 3 times will give you 8. In this case, of course, it's 2. 2 times 2 times 2 is 8. So this the cube root of 8 is 2. So when we say nth root of something, it means that number multiplied by itself that many times. So the second root of 25 is what numbers multiplied by itself 2 times will give you 25. So the second root of 25 is 5. The third root of 8 is 2, because 2 multiplied by itself, 2 times 2 is 4, 4 times 2 is 8. Now, the third root of 16 is, okay, what is that? So what number multiplied by itself, let me put that, gives you 16? The answer is 2.51. It's an irrational on 2.52. So this is approximately 2.52. So 2.52 multiplied by itself 3 times will give you 16. Okay? This. So that's what the nth root means. Okay? So the fourth root of 16 is 2. Because 2 multiplied by itself 4 times will give you 2. So that's what the nth root of a certain number means. So now if I have, for example, 4 to the power of 4/3, okay, this means the third root of 4 to the 4th. That's the 4th stays here, and this is the root. Okay, the third root of 4 to that. Okay, so that can be rewritten as this. Okay. Now the third root of 4 to the 4th, that's 4 times 4 times 4 times 4. That's that. That means 3 of these, right, can come out as 1, right, because that's what the cube root means of something. Is 10 is 10, that's the cube root. You take that out as 4, that's the cube root of 4. So this can be simplified to this. Okay? The first thing that we need to know is when you have a fraction as an exponent like this, it can be rewritten as the nth root of a to the m. Okay. Now, there's one thing that's interesting and helpful, because you have to understand that a to the m over n can be written as this, as I have done. It can also be written as the nth root of a, okay, to the power m. In other words, this m can stay with the a, or it can kind of like go outside of this. Those are two different ways of writing the same expression. Let me rewrite this as 1. So a to the m over n can be rewritten as the nth root of a to the m, or it can be rewritten as the nth root of a to the power m. Okay, and this you have to memorize. I would recommend that you write this like 5 times until you feel comfortable just writing this expression. Okay, let's move on. Now, why is that? So, that's easy enough to explain, inshallah. So you can write this a to the m over n as a to the exponent m, sorry, let me just, times 1 over n, correct? Because we have known from before a to the m to the n to the n equals a to the m times n. That's the rule that we know from before, power of r. So this can be rewritten as this. And this means it's the nth root of that. Correct? Okay. The other way that this can be rewritten as is a to the 1 over n to the power m, for the same reason. A to the m to the n equals a to the m times n, commutative property of multiplication. Right? And then this means this is the nth root of a. That's this. To the power of m. See? So the same expression can be written in 2 different ways, and that's really helpful. Sometimes it's useful to do this. Sometimes it's useful to do that. Okay. So let's do some examples. Okay. Now I have 5 to the exponent of 5/4. We're supposed to write this in radical form. This is exponential as a rational number. We're supposed to write this as in the exponential form. Well, this is going to be, okay, the 4th root of 5 to the 5th. This is 5, 5, 5, 5, 5. So this is the 4th root, so 4 of them can come out as 1. That'll be 5 times the 4th root of 5. One of them will remain over here. Okay? So 5 to the 5/4 is equivalent to 5 times the 4th root of 5. Okay? Let's do another example. Right. How about 3a to the exponent of 4/3? Okay? Well, this can be rewritten as, now look, in this case I put the 5 inside, see? This can be rewritten as the 3rd root, okay, of 3a to the 4th. Okay? 3a to the 4th. So this means there are 4 of these, right? So I can take 3 of them out. So that's 3a. That's 4 of these. So I can take one of them out and there'll be 1 remaining inside. That's easy enough. Correct? Alright, let's do some more examples. How about this one? N to the 4th to the power of 3 over 2. We are supposed to write this as a radical, in radical form. Those are the instructions. Write them as radical form. Well, here we can simply simplify. This is n to the 4 times 3 over 2. Multiply these together. That's because a to the n, a to the m to the n equals a to the m times n. Okay? So, and then you can simplify. 2 goes in there 1 time, 2 goes in there 2 times. Right? That's simply n to the 6th. There is no radical form necessary because it's not a fraction or exponent. That's it. Okay? Let's do this one. 27 p to the 6th to the exponent of 5/3. Now we'll just simplify this. Okay. Well, this is going to be the third root. That's the root. Remember, m over n. This is like the roots of a tree, and this is like the tree. So this goes on the top. This is the root. That's the root. Root is on the bottom. So this is the third root. Let's make yourself a lot of room. So 27p to the 6th to the 5th. Okay, if I did that correctly. All right. Now you can see there are 5 of these in like this. 2, 3, 4, 5, right? Because all of them has 27 p to the 6th, 27 like that, p to the 6th. All of them will this. Okay. So since this is a third root, I can take 3 of them out over here as 1. So this will become 27 p to the 6th and the third root of 27p to the 6th, and there'll be 2 of them left there. Okay. Alright. So then we have 27p to the 6th and the third root of 27 times 27. I can distribute this, right? And then I have p to the 12th. But this is a third root, see? So 27 is 3 cubed, right? 3 times 3 is 9. Okay? Right, 9 times 3, 27. Same thing, 3 cubed. Well, 27, 3 cubed. So I can take 3 cubed as one of them out, and it's a 3, and one of them out as a 3. So this becomes 27 times 3 times 3. And p to the 12th. Okay? I can take that out as, just write this as p. This is that p, 6th. And I can take that out as p to the 4th. Right? Because as 4, right? 4 times 3 is 12. So this becomes 27 times 9, which is what? 27 times 9, 243. 243. And then this simplifies to p to the 10th. Okay? So this is how you simplify radical exponents. Now, the other way we could have done, if we had the foresight, we could say, okay, well, I'm going to take the third root of 27p to the 6th, and then raise it to the exponent of 5. See, here we put the 5 inside and we put the 5 outside. Now here you can see the third root of 27 is 3, and p to the 6 come out as p squared. And that to the exponent of 5. And this will become 3 to the 5th and p to the 10th, and that is 243 p to the 10th. See how different, it's much easier this way, I actually think. So it depends, and sometimes this is easier and sometimes this is easier. In other words, if we have a to the m over n, sometimes it's easier to do this, the nth root of a to the m, and sometimes it's easier to do this. Okay, sometimes it's easier to take this inside, and sometimes it's easier to keep the exponent there outside. But both of them are appropriate. Okay. Now, how about this? A to the 8th to the 3 over 2. Here again, a to the 8 times 3 over 2. Simplify. And that would be a to the 12th. Now, how about this? More rational exponents. What do we do here? Now, these exponents, for one thing, they only apply to the b. It has nothing to do with the 3 over here. Those are private exponents, so to speak. In this case, we use this rule. Okay, so we have exponents here, same thing. 3 times b to the 1/2 plus 4/3. Okay, not to panic. We can handle fractions. Inshallah. So 1/2 to form a common denominator is 6, right? And this is 3 plus 8, 11. So 11 over 6. That simplifies to 11 over 6. That's pretty good. Not bad. Let's do one more. Let's see. How about this one? 3 times x to the negative 1/2 times 3 times x to the positive 1/2 and y to the negative 1/3 over 3 times y to the negative 7/4. When I have negative exponents like this, so this means this x belongs down over here. You can just take that down, and this negative exponent says the y actually belongs on the top. You can take that over there. In other words, if I have x to the negative 2 over y to the negative 3, this becomes y over 3 over x squared. This goes over here, and this goes over here because of the negative exponents. So that's usually the first thing I do. But in this case, you would notice, and probably like I do, inshallah, that I have a negative exponent here, x, and a positive exponent, which happen to be opposites. They kind of cancel each other out because if you add them together, x to the negative 1/2, x to the positive 1/2, you get x to the 0, which is 1. It's not 0. So these actually cancel each other out. So it makes life easier, right? So we can just simply rewrite this. Let's just do progressive logical reasoning. 3 times 3 is 9. And then y to the negative 1/3 over y to the negative 7/4. There's a 3 here. So 3 goes in there 3 times. So 3. And then I can bring the exponents here. It becomes positive 7/4 over 1/3, like this. Okay? And then this simplifies to y 7/4 minus 1/3. Okay? So not to worry, same thing. get the denominators to be the same. 3y to the common denominator is 12. And this is 21 minus 4, 17. So that's the answer. Now, you could have done a over m over a to the n and then a to the m minus n. That's perfectly all right too over here. You could have said, well, subtract this from this. Be negative 1/3 minus 7/4. So you just have to be careful. You still get the same answer like this. But sometimes it's better just to make all exponents positive and then deal with everything. Otherwise, people can get confused with negative exponents and make mistakes. But either way, that is okay. Okay? Now, that's it. I just want to review before I finish here, inshallah. So we learned today that a to the m over n can be rewritten as the nth root of a to the m, or it can be rewritten as the nth root of a to the exponent m, like this. Inshallah, next time we shall continue this and elaborate on these radical expressions and functions. Until then, salatu wassalamu ala rasulillah, alhamdulillah, assalamu alaikum.